students can do research and internships at the same time. Furthermore, the industry can send their personnel to us to host teaching sessions and bring the latest industrial trends to the campus. Therefore, industry-academia cooperation is a win-win strategy. NKUST is located near the Nanjing Export Processing Zone, so the Ministry of Economic Affairs specially appoints us as the university that is entitled to receive counseling from the Nanjing Export Processing Zone. In our experiences over the years, we have created abundant results. Our students would go directly for internships. Moreover, many research results of our teachers go directly to the industry. A lot of companies would like to hire our students, even when they have not yet graduated. Kaohsiung plans to build the Qiaotou Science Park. The planned park will be next to NKUST. We will introduce relevant models to the Qiaotou Science Park. We have designed the Creativity and Innovation Program and the Innovation and Entrepreneurship Program. We hope these programs can help students from different departments to learn and work interdisciplinarily. Brainstorming can help them generate endless creative ideas. Moreover, we advise the participation of creativity competitions, seminars, and exhibitions, both domestically and overseas. Through creativity competitions and various incentive subsidies, we have received precious feedback and abundant results. The Center for Innovation and Entrepreneurship connects the resources of industry, government, academia, R&I, and our dream factory. We assist teachers and students to further produce physical products. From the perspectives of codification of research results and industrialization of creative ideas, we instill in students the traits of innovative entrepreneurs and motivate them to devote and share enthusiastically. We take into consideration all aspects related to curriculum, teacher, and system when setting up plans and making arrangements. From the curriculum aspect, we hope to take each of our colleges and departments as a unit and design an interdisciplinary curriculum. From the teacher aspect, we push forward the professional teacher training program. The main goal is to enhance our teaching quality. From the system aspect, we loosen the restrictions on students' transfers between departments, double major, and minor study. We expect our students to be interdisciplinary talents. In addition to talent cultivation, NKUST also emphasizes holistic education. Therefore, the College of General Education is specially established to help students build the fundamental skills of mathematics, physics, and chemistry. The college also takes measures to improve the students' listening, speaking, reading, and writing skills in Chinese, English, and many other foreign languages, and further, equip them with international mobility. For general education, we design our core curriculum based on the features of NKUST and its principles of featured development. To streamline all our administrative services, we have established 5 divisions. Students can visit the first floor of the administration building on each campus and have most of their inquiries resolved on the spot. If it is not possible to be solved immediately, our staff will deliver the message to the head office. We will manage the task in no time and get back to our students. Art plays a significant role in the student's ability to create, or to say the methods to invent. In fact, a more important role of art is related to the free thinking or open imagination of the students. We have designed many art and craftsmanship-related workshops that offer handmade experiences. These activities to create, invent, and do things by hand are consistent with the core concepts of a technological university. We have promoted our Overseas English Study program for 3 years. We apply every year for the Study Overseas program offered by the Ministry of Education. Approximately every year, we select 150 students to our sister universities as exchange students to participate in the dual degree system. The results prove that study abroad is an effective way to achieve internationalization. It is very beneficial for the students. Also, we send our students abroad for volunteer services every year. The volunteer services are pretty constructive in terms of fostering students' working attitude and career internationalization. NKUST has a strong mission to strive for excellence. We incorporate various principles, including conducting innovative teaching, reinforcing the curriculum in arts and humanities and general and liberal education, and developing students' international mobility. We take our strides toward an exemplary university for internationalized technological and vocational education. We expect to bring hope to imbue every single student with a set of...
Ladies and gentlemen, the opening ceremony is going to start in the next 5 minutes. Please be seated.
Welcome to Southern Federal University, the beating heart of Southern Russia, with a long history and traditions. Located in two beautiful cities, Rostov-on-Don and Taganrog. Over the years, it grew into one of the leading universities, both in Russia and abroad. People from different countries come here to get high-quality education and learn more about the country itself. Southern Federal University has high positions in international rankings. According to the Times Higher Education 2020-2021, SFEDU takes 17th place among 48 Russian universities and became the best at subject rankings in such areas as computer science, engineering science, natural sciences, social sciences. In the QS World University Rankings is number 591-600 among the best universities in the world. Also, the university offers 86 bachelor degree programs, 126 master's degree programs, and 27 doctoral programs. The university is progressive in research and education field. Big amount of scientific research and grants are carried out with Russian and international universities, such as Cornell University, Tsukuba Japanese University, Turin University, Kurchatov Center, and Skolkovo. SFEDU educates highly qualified specialists in natural sciences, engineering, humanities, architecture and arts, pedagogical education. Every year more programs emerge, so that each student can get knowledge and skills for their personal and professional development. SFEDU is a great place for everyone. Comfortable living in students' campuses, modern sport and studying infrastructure, friendly atmosphere and unforgettable life experience. Join us and explore all opportunities that SFEDU offers.
Excellencies, distinguished guests, participants, ladies and gentlemen, Assalamualaikum warahmatullahi wabarakatuh. May peace be upon you. Selamat pagi, salam sejahtera bagi kita semua. Shalom, Om Swastiastu, Nama Budaya, Salam Kebajikan.
Good morning, and we are delighted to welcome you to the theater room of Universitas 17 Agustus 1945 Surabaya, Indonesia, for the opening ceremony of 2023 International Conference on
Physics and Mechanics of New Materials and Their Applications, or PHENMA 2023.
My name Dinda Lisna Amelia, and
my name is Dika Ayusa Fitri. We both will accompany all of you during today's agenda of PHENMA 2023. Hosted in the city of Heroes Surabaya, UNTAK Surabaya has the honor to present you this international conference. This conference is presented by Faculty of Engineering Universitas 17 Agustus 1945, or known as UNTAK Surabaya.
These conferences bring together academia, researchers, university students who are responsible for updating in the insight on physics and mechanics of new materials through leveraging advanced engineering and technology. This conference provides great opportunity for prospective participants to share their recent theoretical knowledge, research findings, and experiences in dealing with sustainable engineering and technology. As such, these conferences will feature presentations by international speakers with cutting-edge session topics.
It is an honor to me to introduce and welcome the guests at our table. Director of UNTAK Surabaya, Professor Dr. Mulyanto Nugroho, MM, CML, CPA.
Vice Dean of Engineering Faculty of Untak Surabaya, Associate Professor Gatot Priyo Utomo.
Keynote speaker from Southern Federal University, Russia, Dr. Yuri Drobotov, which represents Professor Ivan Parinov from Southern Federal University, Russia.
Keynote speaker from National Kaohsiung University of Science and Technology, Taiwan, Professor Dr. Sun Xiong Chang.
Keynote speaker from National Kaohsiung University of Science and Technology, Taiwan, Professor Dr. Hung Yu Wang.
Keynote speaker from Untak Surabaya, Dr. Imade Kastiawan.
And also we welcome all the presenters and participants of PHENMA 2023.
For a brief moment, we would like to invite all of you to rise and sing Indonesian anthem, Indonesia Raya, and Untak hymn. May all we rise.
Ladies and gentlemen, we are now present you the dance of Jejer Jaran Dawuk. This dance originally from Banyuwangi, East Java province. It has special meaning as symbolizes the moment of welcoming harvestation of the staple food. As we are aware that Indonesia has diversity in the term of staple food, not only rice but also cassava, sweet potato, yam, and tubers that in Bahasa Indonesia we call as umbi-umbian. Ladies and gentlemen, please welcome Jejer Jaran Dawuk dance.
Dimulai Kang nomor 1 ben tekon daung sarta wong unak termeno angkat sampur dimulai aper. Kang nomor 2 pengen telu endase pundake nyang bokong itu angkat sampur sekarang dimulai aper. Nyepak kodon angkat sempur timur aper. yang kandangnya dek-dek angkat sempur sekali dimulai.
Ladies and gentlemen, we are now going to listen the first opening speech delivered by the Technical Committee Chairman of PHENMA 2023. Ladies and gentlemen, please welcome Dr. Erni Puspanantasari Putri.
Assalamualaikum warahmatullahi wabarakatuh. Peace be with us all. Salam, Om Swastiastu, Namo Buddhaya, Kandekar. Good morning all. An Honorable Head of Yayasan Perguruan 17 Agustus 1945 Surabaya, Jesu Bekti SHMM, and then an Honorable the Secretaries and Treasurers of Yayasan Perguruan 17 Agustus 1945 Surabaya, an Honorable Rector of Universitas 17 Agustus 1945 Surabaya, Profesor Dr. Mulyanto Nugroho MA CPA, an Honorable First and Second Vice Rectors, an Honorable Head of Research and Community Service Institution, Academic Development Office, Quality Assurance Office, Cooperation Office, Biro Dean and Lecturer of Untak Surabaya, and also welcome to our campus, the Red and White Campus, to the delegation of Southern Federal University Russia, which is led by Dr. U.A. Dobrotov, represent Professor Dr. Sayan Ivan Aparinov as chairperson of PHENMA 2023. Welcome to the delegation of Taiwan, which is led by Professor Dr. Sun Yung Chang from National Kaohsiung University of Science and Technology as co-chair PHENMA 2023. And welcome to the delegation of India, Dr. Pratek Upadhyay from PDPM IIT-DM Jabalpur. Ladies and gentlemen, first of all, we should give thanks for the presence of God Almighty, because by His grace, we can be present together today to take part in the activity of 2023 International Conference on Physics and Mechanics of New Material and their Application, or PHENMA 2023. Ladies and gentlemen, PHENMA 2000 will run for 6 days as follows. The October's arrival and agitation. For October, today is opening ceremony, plenary report, oral, video presentation, and poster session, and continue on 5 October 2023 with plenary report also, oral, video presentation, poster session, closing ceremony, and gala dinner. And on 6 and 7, we have the culture trip, and finally we finish on 8 October 2023 of a departure of participants. Participants come from 6 countries. Actually, we have around 350 abstract in proceeding, but for this conference, there will be 26 oral presentation, 12 video presentation, and 45 poster. This is come from 6 countries: Indonesia, Russia, Taiwan, India, Iraq, and Egypt. There are 4 keynote speakers from 3 countries: Indonesia, Russia, Taiwan. 2 Indonesia speaker from Universitas 17 Agustus 1945 Surabaya, Dr. Imade Kastiawan and Dr. Ani Puspanantasa Putri. Russian speaker Dr. U.A. Broto from Southern Federal University Russia, and Taiwan speaker Professor Dr. Hung Yu Wang from National Kaohsiung University of Science and Technology. And 2 moderators from University 17 Agustus 1945 Surabaya, Tigor Wilfried Soaduan Panjaitan, Dr. Intan Zikiria. Ladies and gentlemen, this is the report on the 2023 International Conference on PHENMA. Hopefully the PHENMA 2023 can run smoothly and can provide benefit for all participants. Thank you very much.
Thank you, Dr. Ernie. We are now going to listen to the second opening speech delivered by Vice Dean of Engineering Faculty, Untak Surabaya, Associate Professor Gatut Priyo Utomo. Ladies and gentlemen, please welcome Mr. Gatut.
Bismillahirrahmanirrahim. Yang kami hormati Bapak Ketua Yayasan Yesu Bekti beserta jajarannya. Yang kami hormati Bapak Rektor Profesor Dr. Mulyanto Nugroho MMCPA beserta jajarannya. Kemudian sahabat-sahabat saya pejabat struktural yang ada di Untak Surabaya, sahabat-sahabat PENA yang ada datang di sini dari Rusia, kemudian India dan Taiwan, saya juga ucapkan selamat datang. Kemudian adik-adik dari mahasiswa teknik yang kami cintai, Assalamualaikum warahmatullahi wabarakatuh. Salam Swastiatu, namun budaya, salam kebajikan rahayu. Selamat datang dan selamat bergabung dalam seminar internasional PHENMA yang luar biasa ini. Kami sangat senang Anda dapat bergabung dengan kami di acara ini, yang menghadirkan para pemikir terkemuka, di antaranya adalah dari Rusia, Taiwan, dan India, untuk berbagi pengetahuan, pengalaman, dan wawasan yang berharga. Hari ini adalah momentum penting dalam perkembangan ilmu pengetahuan dan teknologi, di mana kita memiliki kesempatan untuk mendengar dari para ahli di bidangnya yang akan membahas topik-topik terkini dan relevan. Acara ini adalah wadah untuk memperluas wawasan, membangun jaringan, dan mengilhami perubahan positif di berbagai bidang. Seminar internasional ini juga mencerminkan komitmen kami untuk meningkatkan pemahaman global tentang isu-isu yang kompleks dan mendesak, serta mempromosikan kolaborasi di antara teman-teman yang datang di sini. Selama seminar ini, mari kita terbuka terhadap perspektif-perspektif yang kita tanyakan, pertanyaan-pertanyaan yang sulit, dan mari kita berusaha untuk menciptakan pemahaman yang lebih tentang dunia yang kompleks ini. Saya yakin kita semua akan meninggalkan acara ini dengan wawasan yang lebih mendalam dan ide-ide yang inspiratif. Sekali lagi, selamat datang di seminar internasional PHENMA ini. Kami berharap Anda semua dapat memanfaatkan sepenuhnya pengalaman ini, dan kami berharap seminar ini akan menjadi kolaborasi yang inspiratif. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Mr. Gatot. Ladies and gentlemen, in brief, the opening speech from Mr. Gatot was explaining our commitment to increase global understanding of complex and urgent issues and promoting cross-border collaboration in research and innovation. Mr. Gatot believed that by sharing knowledge and ideas, we can together find the best solutions for today's world challenges. We are now going to listen to the third opening speech delivered by the Rector of UNTAK Surabaya, Profesor Dr. Mulyanto Nugroho, MM, CMA, CPA. Ladies and gentlemen, please welcome Profesor Mulyanto.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning everyone. Shalom, Om Swastiastu, Namo Buddhaya, Salam Kebajikan, Rahayu. Before I give a speech, let's shout the Indonesian national greeting. Merdeka! Merdeka! The Honorable Head and Foundation Perguruan 17 Agustus 1945 Surabaya, Master J. Subekti SH MM, and Secretary Treasurer of Foundation, Bapak Anom dan Pak Ontot, the Honorable Vice Rector 1 and Vice Rector 2, Master Harjo Saputro STMT, and Dr. Abdul Alik MM, Dean of Faculty of Engineering, Dr. Engineer Sajio MKes, Head of Research of Community Service Institute, Aris Heri Andirawan STMT, whom we respect, three partnering university who coordinating the conference, Dr. Erni Puspinatasari Putri from UNTAK Surabaya, Professor Dr. Ivan Parinov from Southern Federal University Russia, today not attend because he is sick. Professor Dr. Sun Hyang Chang, I call Prof. Chang, from the National Kaohsiung University of Science and Technology Taiwan. Please stand up, Prof. Chang. The first meet you in Busan. Okay, nice to meet you. Okay. And the excellent ladies and gentlemen, all of the keynote speakers, presenter, and participants from various universities all over the world. First, I say welcome to physics and mechanics of new material and their application, PHENMA 2023. Welcome to Untak Surabaya. We usually abbreviate Untak Surabaya, famous as the red and white campus and nationalist campus. Untak Surabaya is one on the university with excellent accreditation in Indonesia. In Indonesia, there are 4,400 public and private universities. Untak Surabaya, which rank 53rd in the East Java level, Untak Surabaya become the overall champion in 2023 out of 328 private university based on the ranking of highest education service institution. We are happy and proud to welcome you all to this occasion at Untak Surabaya. This conference is an important milestone in the world of science and engineering because it brings together brilliant minds from around the world to explore the boundaries of new material and their application. With rapid technology advance and global challenge, the research of material has become very important. I look forward to your active participation in this conference, sharing innovation research finding, and fostering international partnership. I would like to express my deepest gratitude to the organizing committee and all the participants who have traveled long distance, especially from Russia, which took 3 days or 25 hours. That's right? To join us to today conference at Untak Surabaya. Finally, I really hope you will enjoy it with fun. Hopefully, this conference will be filled with things that inspire insight and fruitful collaboration and the advancement of the field of material science. Thank you very much. Good morning. Wassalamualaikum warahmatullahi wabarakatuh. Om Santi Santi Om. Thank you very much. Merdeka!
Thank you, Professor Mulyanto. We are now going to listen to the first Congress address from Professor Dr. Sun Xiong Chang from National Kaohsiung University of Science and Technology, Taiwan. Ladies and gentlemen, please welcome Professor Chang.
Selamat pagi. Nyunyang. Good morning, ladies and gentlemen, distinguished guests, and esteemed colleagues. As the co-chair of the PHENMA International Symposium of the 2023, it's both privilege and honor to extend a warm welcome to each and every one of you here today. This symposium has a rich history, and 2023, we stand together to continue championing the core values of the have defined PHENMA over the years. Before we plunge into the essential of the symposium, I would like to take a moment to express our sincere appreciation to some key figures whose unwavering support and and dedications has been instrument in the bring this event fruition. First and foremost, I would like to offer my heartfelt gratitude to my best friend, Dr. Supati. Supati, yeah. Head of the Yasansan programs of Buddha. Your visionary leadership and steadfast support has been in the cornerstones of this event. To our esteemed co-chair, Associate Professor Dr. Ernie, and Putri, your dedication and expertise has been invaluable in shaping and the direction of this symposium. Thank you so much, Dr. Ernie. And I also want to acknowledge also Professor Sergio Dean of the engineer faculty, and for your academic leadership and the significant contributions of our events. Thank you so much. And to the Professor, the President, Mo Yang Zhen, Mo Yang Du, yes, yes. Okay. We extend our gratitude for your unwavering dedications and profound insights, which have greatly enriched our discussions. Thank you so much. And the last, but certainly not least, the heartfelt thanks to our co-chair, Professor Ivan Panilov from Russia, and for the South Federal University, for bright and international perspective, and fostering a collaborative spirit within our symposium. Moving forward, our commitment remains resource in bringing together researchers from across Asia and the Asia-Pacific Ocean region and beyond. Our collective aspiration to promote international academic research and to strengthen scientific collaboration that transcends borders. The journey of the PHENMA symposiums is a testament to resilience, passion, and unwavering dedication. Guided by the common purpose, we aim to share and celebrate the latest advanced in the fields of the materials synthesis and processing, especially characterization and research methods, and especially in the underwater technology, biomedical engineering, and industry and management. While we primary focus remains on this vital area, we are excited about the boundaries, possibilities, and innovations with these dynamic fields. This symposium represents the culmination of the tireless efforts from the research scholars around the world, beyond our academic and endeavors. What binds us in the sense of the friendships has burst with our team. We take immense pride in presenting our research findings with the hope that we contribution to pave the way, the better and the more interconnected global society. This year, we have gathered in Surabaya, Indonesia, known as the City of Heroes. This city, with its rich history and cultural diversity. Surabaya perfectly embodies the spirit of the unity in diversity that our global community holds dear. Its story to resilience and growth resonates deeply with the ethos of symposiums. In conclusion, to all our dedicated team members and the participants, I extend my best wish to your time here to be filled with enlightenment, insight, fruitful collaborations, and lasting memories. Thank you, and Selamat Datang. Welcome to everybody to our PHENMA 2023 in Surabaya. Thank you so much. 谢谢.
Thank you, Professor Chang. Ladies and gentlemen, we are now going to listen the second congrats address from Dr. U.E. Drobotov from Southern Federal University, Russia, which represents Professor Ivan Parinov from the same university, Southern Federal University. For Dr. Yuri, ladies and gentlemen.
Good morning. Unfortunately, Professor Parinov had no opportunity to join us today, so let me pronounce his speech as if he is attending this honorable ceremony. Dear ladies and gentlemen, today we, together with my friends Dr. Putri and Professor Chang, open our annual conference on physics and mechanics of new materials and their applications, PHENMA 2023. Here in Surabaya, in Indonesia, as in 2016. Regretfully, some geopolitical circumstances introduced specific changes in the plans of our foreign friends and partners. Therefore, we continue to hold PHENMA conferences in online, offline mode. Nevertheless, I am very happy that organizing committee coped with the existing problems with honor. Our conference continues the topics of our previous conferences, which had their place in Russia, Taiwan, Thailand, Indonesia, India, South Korea, Vietnam, and Japan. The scope of our conferences includes modern materials and composites, their synthesis and processing, physical and mechanical characterization and research methods, numerous applications, in particular underwater technologies and biomedical engineering, and also industry and management. The main goal of our conference is to attract researchers from various countries of Asia and Asian Pacific Ocean region, as well as from other countries to carry out joint investigations and establish educational and scientific cooperation. Scientific and educational collaborations obtained their acceleration due to PHENMA cooperation led to obtaining by our teams of a set of joint international grants, in particular by scientific foundations of Russia and Taiwan. Many participants of PHENMA conferences could use their experience for submitting their scientific proposals, preparation of numerous scientific reports and publications, PhD and Doctor of Sciences theses. There are significant possibilities for foreign students of different levels to continue their education in the Southern Federal University of Russia. I am very glad to know that PHENMA 2023 aroused significant interest and organizing committee accepted 367 abstracts of authors from 12 countries. Full text reports will be published by leading world book publishers and on the pages of high-rating journals. Our conference has attracted the attention of very many young scientists, students, and PhD students. I am sure that participants from different countries will obtain invaluable experience in presentation of their scientific results, establish new scientific and educational mutual collaboration which will help them in their further scientific career. I know that our conference will be held in a very friendly and warm atmosphere. I wish great success to our conference and congratulate all the participants with its opening. Thank you very much.
Please, Dr. Yuri. Dr. Yuri, please don't leave the stage, please. Just stand in here. Ladies and gentlemen, the next agenda is souvenir exchange following by the group photo session. We would like to invite the Rector of UNTAK Surabaya, Professor Mulyanto Nugroho, Dr. Yuri Robotov, Professor Dr. Shun Shung Chang, Professor Dr. Hung Yung Wang, Dr. Imade Kastiawan, Dr. Erni Puspanantasari Putri to the stage. Ladies and gentlemen, give the big applause for this session. Give a big applause, ladies and gentlemen. Big applause, ladies and gentlemen. Thank you so much. Okay. For photo session, please stand up. And all students, please stand up. Yeah.
Ladies and gentlemen, we have this tradition in UNTAK Surabaya every day in 10 a.m. we will stand up and sing our national anthem, Indonesia Raya. So it is still less than 2 minutes. We will wait. Okay, so we will, starting now, please stand up. Everybody may sit, please.
Ladies and gentlemen, before we move on to the next agenda, we have 5 minutes break to prepare the plenary report season. However, we please the rector along with the vice rector and the head of YPTA Foundation to leave the opening session as the next agenda will begin.
Ladies and gentlemen, we will start in next 2 minutes. Please be seated. Okay, ladies and gentlemen, we will start the next session, so everybody please be seated. Ladies and gentlemen, welcome to the main session of PHENMA 2023, We are now continuing the next agenda, that is Plenary Report 1 and 2, which will be delivered by Dr. Yuri Drobotov from Southern Federal University, Russia, and Dr. Made Kastiawan from UNTAK Surabaya, Indonesia. This session will be moderated by Dr. Tigor Panjaitan. For Mr. Tigor, the time is yours. And for Dr. Yuri and Dr. Made, please to take seat in the stage. Satunya.
Okay, thank you. Good morning, everyone. It's glad for us for your participating to this our international conference. Today conference is about the physics and mechanics of new materials and their application. I believe not all of you came from mechanic and electrical department, right? But I think you can learn many from this discussion. In this plenary report session, we will hear a presentation from our two presenters. They are very expertise in their field. First, Dr. Yuri Drobotov from Southern Federal University, Russia. And the second presenter was Dr. Imade Kastiawan, STMT from Mechanic Department. I think his face is very familiar to us, I think, yeah. And this is an important moment for all of you guys, our students, because Dr. Made Kastiawan also came here as a representation of your alumni. Dr. Made graduate from Mechanic Department, Mechanic Engineering Department in UNTAK Surabaya. This moment will show that he have a capability in international level, and then we also believe that the door is open. Your time will become for you, all our students here. And ladies and gentlemen, this session will be divided, become two parts. First part will be here the presentation from our speakers, and then continue with the discussion. Maybe each presenter give around 15-20 minutes. It's enough, or? It's enough. Okay, it's enough. Okay, after the presentation, the second part will continue with discussion, maybe around 30 minutes, or depends on what time we have. Before we start the presentation, I want to introduce our presenter today, the brief profile. The first speaker is Dr. Yuri Drobotov. He received his bachelor in mathematics from Southern Federal University of Russia in 2014. He accomplished his PhD program in 2022. He also a lecturer in mathematics. And right now, he is a senior lecturer at Dawn State University. Is it correct? Okay. As a lecturer, he delivers special courses on programming and mathematical methods in computer sciences. Dr. Yuri Drobotov will present his paper with title The Solvability of Integral Equations of the First Kind with Mild Singularity Kernels. This is new for me because my background from architecture, I'm not really familiar with the terms. The second speaker is Dr. Made Kastiawan. He received his bachelor degree in mechanical engineering from UNTAK Surabaya, and then completed his master degree in manufacture engineering from UI, University of Indonesia, and accomplished his PhD program from ITS, Institut Teknologi 10 November Surabaya in 2021. Currently, he works as a lecturer in mechanical engineering. His expertise in natural composite material. I think that's what I can explain. Okay, now for the first Please welcome Dr. Yuri Drobotov. This is your time. Give applause for Dr. Yuri Drobotov. Thank you.
Thank you very much. So, dear colleagues, I'm extremely flattered to share the stage today with the respected Professor Madi, honorable participants of the conference and organizing committee, whom I would like to thank for such a pleasant and hospitable attitude. The talk of mine is on a mathematical theory which is becoming more and more popular these days within its applications in various problems of mechanics and physics. So I believe we just a little bit wait. Okay, thank you very much, thank you. So this report is carried out together with my scientific advisor, Professor Boris Vakula from the Southern Federal University of Russia. Now I'm working and continuing these studies at North Caucasus Center for Mathematical Research of the Vladikavkaz Scientific Center of the Russian Academy of Science. And the topic of my today's talk is the first kind integral equations which are produced by non-standard operators, non-standard integral operators. So I would like to present you a class of integral operators which have mild singularity in the kernel. So the singularity of these operators is less than the dimension of the space in which the integration is carried out. So can we see the next slide, please? Okay, thank you. Let me start with the most general problem statement in this field. So assume there is a metric space called here X curve, which is equipped with a distance function and measure, which makes sense for any points of this metric space. To characterize this abstract metric space, we need some kind of dimension, yeah? So we applied the following growth condition, which is implied on the balls in this metric space. So every ball which is located at an arbitrary point X of this space must have measure which is not exceeding the radius of this ball, powered by some some perimeter n, which can be real, so it's not necessarily integer. So we are considering the closed balls, which are defined like it is shown in the frame on this slide. Please, the next slide. Assume that there is an operation which we'll call an integration operation, so it is assumed to satisfy these basic properties of an integral. The first one is on the sum of the integrals carried out over the subspaces or subsets of the area of the integration region. The second one is subadditivity property, and the third one is like the order of this operation. Yeah. So this operation implies the existence of some ordering in the terms of this condition. Can we see the next slide, please? Thank you. So consider an open bounded subset of this metric space, which we will call and symbolize by omega. It is non-trivial, and also fix some kind of order of integration, which is alpha here. And alpha is assumed to be complex, with the real part not exceeding the value of 1. The following is considered here as the risk potential. So the risk potential operator is presented in the frame, where for short we will skip the notion of the metric, as it doesn't play any specific sense, any specific role here. So you can see that the relation under the sign of the integral is is implying that there is some singularity in the kernel, but this singularity is not so big as the value of n. And this is the main feature of such kind of apparatus. Please give us the next slide. Okay, thank you. Let me also recall some geometric notion, geometric term which is widespread in the geometry of metric spaces. So a surreactive mapping, which is denoted here by phi, which maps one metric space to another one, but with different metrics. So this mapping between two metric spaces is called a submetry if for any point x the following hold for any closed ball centered at x. So the condition in the frame must be satisfied. It states that the ball is preserved by this mapping. So if we have a ball and map it to another space, its structure, it remains the same, but only the center is, of course, another point. Yeah, it is the image of the initial center. So, and the radius remains the same. And I must say that it is widespread nowadays in mathematics to combine the terms from different branches of mathematics, from different areas of study. I think that such an approach can lead to acceleration of knowledge in general. For example, this condition can be also considered as the condition of I'm sorry for this, repeating, the condition of conditioning of this mapping. So, I mean, if we have some initial data provided as the ball B, so, and we translate it by the mapping phi to another metric space, it becomes like the ball of the same radius, but in another terms, and in other set of terms. I think that this might interest, for example, those researchers who work in the field of computer sciences and data mining, for example, because in data mining and data science, it is very important to pick up the right metric of the data and to, to follow the all the transformation of the data qualified, yeah? So give us the next slide, please. Thank you. So to characterize the submetry of one or another mapping, we use the modulus of submetries, the so-called modulus of submetry, which it was introduced firstly in the works of my scientific advisor, Boris Vakulov. It is associated with the region omega and also the function f, which is now acting from an arbitrary metric space to the space of real numbers. So it is a function. And the modulus of submetry then indicates what is the distortion of the submetry, yeah? How submetric can be the function f. So, and here we assume that all the points we consider are in the region omega. Give us the next slide, please. Thank you. So, we define the space of function which satisfy the condition which is labeled here by the letter H. So this is the condition on the modulus of submetry, not to exceed some function, to be predictable, of predictable growth. And this function on the right side is the characteristics of the space, which we will assume as the generalization of a Gilder space. So it is a widespread function space in theory of equations of partial differential equations, for example, in integral equations, the Gilder spaces. The continuity in the terms of the Gilder condition is very fruitful for investigating the properties of the solutions of these equations. So we generalize this property by using the term of the modulus of submetry. And the weighted analogous of these spaces is defined in a natural manner as it is shown in the second frame. So we have some kind of a multiplier or a weight denoted here by W small in order to provide the function which is initially not in the space belong to this space of generalized Goldarity. Please provide us with the next slide. Thank you. So, but this, in the same time, the modulus of submetry is a pure geometric concept. So it is not good for analysis, for carrying out analytical, investigations of the solution's properties. In order to provide us with such analytical instrument, we need the notion of the modulus of continuity. So we can see that the submetry is very related, very strictly connected with the notion of continuity, because if the function is submetric, then in the, for example, we can formulate the Cauchy type condition in this term and consider it as the condition of continuity. So a function which is called here omega f, associated with the mapping f, is called the modulus of continuity if it satisfies the following properties. It must be 0 at the 0 point, it must be a non-decreasing function, and it must be a semi-additive function, which means the condition which is framed at, in this slide. So all of these properties, sometimes they are not given in this order or in this, amount. Sometimes the author introduces the notion of the modulus of continuity in his or her own way, but we strive for formulating a generalized and at the same time complete theory. So we have some background in this field, and that's why these conditions are the most popular in this field of study and the most fruitful for the corollaries. So let us see the next slide, please. Thank you. These are the corollary properties of these basic properties. So the first one states that if the ratio of the modulus of continuity, so the parameter of the modulus of continuity, is multiplied by some real number, positive number, so then the relation which is labeled here as omega f1 takes its place. Also, the second fact appears, and both these facts are very important for the further representations, the further expressions we strive for. I suppose we can assume them for now as some kind of technical facts. So give us the next slide, please. Thank you. So we need to explore the connection between the modulus of submetry and the modulus of continuity. In order to do that, we consider here the local oscillation of f, which is defined in a pretty similar way as it is done in the classical analysis. So the supremum of the absolute value of the difference of the function at two neighborhood points is called the oscillation of this function. And it is a modulus of continuity on the intersection of the initial region with the ball centered at the given point. So we can consider the local oscillation and the local modulus of continuity. And this local modulus of continuity measurizes, as we say in our theory, the modulus of submetry. So the second frame shows this fact. So it is to demonstrate that the modulus of submetry can be measurized by the function for which all the previous properties are guaranteed. And for the modulus of submetry, they are not guaranteed. I must say that semi-additivity holds even for only for good functions, yeah? But we need to consider a great amount of functions, so greater amount of functions. So we need something to measurize our modulus of submetry and to have the desired properties. Give us the next slide, please. Thank you. Here, the basic facts, the basic lemmas we use in this theory are presented. They were proved in the paper of my scientific advisor with his scientific advisor, Stefan Grigorьevich Samko, Professor Samko, who is very famous in the field of function analysis and operator theory. In Russia, he is one of the founders of this field of study. And we can see here that if we have an integral, which is, we will call it multidimensional, but it is more generalized, more complex, even more complex structure, yeah? So it is the integral over a ball in a metric space. So this integral can be estimated through the one-dimensional integral, which can be calculated. Or which can be estimated as well. So, and the same fact holds for the relative complement of this ball. So for all the area which is outside this ball but belongs to the initial region. These two basic facts are directly used in our representations. Give us the next slide, please. I must say that the constant CL from the previous slide is evaluated and can be used for example, estimating the approximation properties of these constructions. In this slide, we can see the theorem called Theorem Z. Which states for Zygmunt type theorem. So the Zygmunt type theorem states that if we have the power weight function with the parameter nu, which is called here, which is assumed here to be positive, then the following, which is framed here, holds for the for this relation, yeah? So if we have at the right side, we have, I must say that these functions on the left-hand side of this inequality are assumed to be the images of carried out by the Riesz potential type operator. So this difference of the images can be estimated through the integral over the modulus of submetry of its pre-image. Give us the next slide, please. Thank you. So this theorem is very important, though it is technical. Now we are striving to formulate the general result, which will be our guide to the investigation of the first kind integral equations with Mie singularity. So in order to formulate these conditions, we need the class called W here. So if we have this kind of Descartes or Cartesian product of omega, which is our initial region, by the segment from 0 to L, where L not exceeding the diameter of omega. So the function then belongs to the class W if it satisfies the following three conditions. It must be continuous, it must be positive, and almost increasing in T for all axes from this region. So this class will be used to bound us, to limit our choice of characteristics in the Gelderian condition. So can we see the next slide, please? Okay, thank you. The subclass of W, which we will use directly, is the Boris-Stechkin classes. The Boris-Stechkin classes. So we say that the function omega, which is intended to be a characteristic, belongs to the class which is called Boris-Stechkin class, if the following two conditions hold together. If only one condition holds, then we talk about only one Boris-Stechkin class with the respected, with the corresponding index of this class. And these classes are used to estimate those one-dimensional integrals by the characteristic function. And this is very important for us, as the characteristic function can be assumed as the measure of conditioning of the integral equation. So can we see the next slide, please? Thank you. And this is the main theorem I would like to pay attention to and to emphasize in my talk. So if the characteristic function is from the Boris-Stechkin class, then the following mapping by the Riesz potential type operator is bounded. So this operator is bounded while acting from the generalized Golder space with a power weight to the another generalized Golder space whose characteristic is represented through the initial characteristic. So we can say then that the Riesz potential type operator improves the initial continuity. And also I must say that the space H omega is Banach with respect to the following norm. So it allows us to bring all the instruments from the analysis on Banach spaces to this theory and to formulate the conditions or to investigate the conditions for the first kind integral equations with mild singularities to be solvable in such spaces and to have predictable smoothness of their solutions. So what is about my time? 5 minutes. Okay, thank you. So then I would summarize my talk. I must summarize it in the following way. These kind of studies are purely mathematical, but mathematics come to other areas of knowledge explicitly. And for example, these kind of theorems are widely used in dielectrics modeling, for example, ferroelectrics modeling. And one of such models was carried out together by Russian and international scientists, and it implies the solving of a theorem with such of solving an equation with such kind of an operator. So we need some instruments to estimate the possibility of solving such equations and to predict their being smooth, their solution being smooth and continuous in such a general way. And recently we have published a monograph with Professor Parinov, which is devoted to these questions also, to these issues also. If you wish, I can provide you the links to this work and also the corresponding works. And please go, you can reach me by my email. Could you please show the first slide in order to represent my data? Yeah, just you can drop me email and I will provide you with any information you need. So thank you very much for your attention.
Okay, like Dr. Yuri said, that this is purely mathematics. I try to understand. Yeah, it's okay. Yeah, like what you said, that mathematics come to many areas. Yeah, this is like a pure science that can help to solve many problems. I think we'll be continuing in the discussion in the part 2, and I hope all the audience can prepare the questions. Before that, this is time for Dr. Made Kastiawan to present his paper. Please give applause to Dr. Made.
Okay, thank you very much for my time. Thank you, Mr. Tigor. Okay, I want to greeting everybody in this room. Good afternoon, everyone, ladies and gentlemen. esteemed colleagues, yeah, and fellow learners and researchers from several countries like Russia, Taiwan, and India. Yeah, thank you very much. You come to Untak Surabaya. Yeah, this time I want to explore about my research. Yeah, I think it's a very different with Mr. Yuri. Yeah, he has have research pure of mathematics, but from me, I will try to discuss about material. Yeah. Okay, it's okay. Okay. Please follow. I use the laptop. It's okay. Okay. Maybe you can share my slide. Okay. Okay. Thank you. Sorry. Maybe I wrong sent my file. I sent to Mr. Tigor. Yeah. Sorry. Okay. We need a minute? Yeah. Sorry.
No.
I wrong sent. Okay. Well, wait. Before the slide is work, it's okay. I try to explain about my research. Okay. Okay. I will bring the topic of my research adalah mechanical study of coconut shell particle reinforcement polypropylene matrix toward an environmentally friendly alternative material. Yeah. Okay. We know in the development of the world of technology, material need will definitely follow, and then the demand amount of material will increase. Yeah, will increase while the source of material from metal will decrease. It is a problem, maybe. Yeah, if the technology increase and have many develop, it must need many material, kind of the material. Yeah, and then and we know too the environmentalists, yeah, demand that the always remain material user to use material that do not damage, yeah, the environment. Yeah, they okay. Next slide. Yeah. Next slide. Okay. Yeah. This is the condition. Yeah. The material always need to to development of the technology. Yeah. So we know the material user. Yeah, one material that are light, strong, and cheap. Yeah, yeah. But the resources, metal of material always decrease. Yeah. So, okay. Environmental lover expectation. Next. Okay, thank you. Environmentalists always remind the world community that the material used at least do not pollute the environment. It is hoped that we use technical material for all daily needs and for the technological sector, which are environmentally friendly and easily decomposed by nature. Next. Okay, I think this condition make two challenges by for our academic or researcher. Yeah, how to answer the demand for user and for environmentalist lovers. Yeah, academic researcher for new material have a big challenge. Yeah, if we face the condition, yeah, the research result must respond, yeah, to emerging needs provided by material user and environmental lover, namely material that are strong, yeah, light, cheap, easy to manufacturing, and environmentally friendly. Seeing the limitation, yeah, of the demand given, one of the material that must be developed is natural material. I think like that, yeah. We see how the condition user of the material. I think we must think about how can to make new material from nature. Yeah, yeah. We will study, so yeah, enough time to study for the new material by method of composite. Yeah. I think the composite can to answer the condition. What can I do to make the natural material and maybe like polymer, so they can do new material to change, yeah, to change the material like metal and easy, yeah. Okay, natural matrix material are a challenge for researchers, so that in the future they will be able to create material that are completely natural. But until now, in Indonesia especially, we know we have very much reinforcement, yeah, in Indonesia, but we don't find the material for the matrix. Yeah. The composite have two ingredients. One is as a matrix, and number two as a reinforcement. Yeah. Yeah. Okay, next. Indonesia's potential. Indonesia, as a tropical country, has many natural resources that can be used as alternative engineering material. This material include renewable material. Yeah. However, so far the material that have been found can be used as reinforcement. Yeah. Like the type of the natural fiber as reinforcement in Indonesia, like corn fiber, cotton, pandan leaf, flag, banana, coconut, and so many we can find in Indonesia. Yeah. But until now, we try to research to find a matrix. Yeah. What can that can use to composite, so to be natural completely. Yeah. Okay, next year. This is a result of my research. Yeah. Coconut shell particle reinforced polypropylene matrix. We can see in the graph, yeah, the reinforcement coconut shell particle can to improve the strength of the polypropylene murni, polypropylene pure polypropylene. This is, we can see, they have the value is significant. Yeah. This figure shows that the additional of coconut cell particle has an impact on composite strength that is greater than the pure matrix condition. These results also show the size impact tensile strength. Yeah. We can see and we try to observe about the condition. The finer, smaller diameter of the particle provides smaller tensile strength value. Yeah. If we compare to a large particle size. Yeah. Yeah. I think if we can to the deep to observe that, we can know what is the cause. Yeah. The condition can be like the result. Yeah. Okay. Next. This is tensile strength. Yeah. Before we can try to observe and know the size of the material, very influence the condition of the matrix, the condition of the material composite. And then this slide we can to show you that the mixing speed and duration can to also influence the strength of the material. Yeah. So this is the problem. We know by the result of the material how occur in the material with the mixing speed and duration. We can see many defects, yeah, in the material. Okay, next. This is a slide to show a modulus of elasticity. Yeah. Size to influence, yeah, the condition of the composite material. Yeah. This condition shows that the providing reinforcement with coconut shell particle actually increases the ability to deform. Yeah. This is due to the presence of coconut shell particle, which provide more opportunity for slippage. So we can know about this from the result. If we want to give the composite to have a high strength, we must to know about how about the size of the particle and how about the to manufacturing of the composite, like mixing and like duration and speed and etc. Okay. Next. Okay. This is a value. We know from morphology of the composite material. There is we find 4 conditions. So the material the material make the material to decrease of the strength of material. Number 1, clearance interface. Yeah. We until now I don't know how about how the methods we can use to increase the defect, yeah, in the material because matrix that we use is have high of viscosity. It's just the problem for me to make the the composite material. Okay. Number one, clearance interface. In the interface area, a fairly large gap form, which indicate that the interface bond is not occurring properly. It can be seen that there is the bonding and pull out. It is the problem, yeah, in our material. Okay, next slide. Number two, it's a bad condition in the material adalah pore. It's a pore, yeah. It's too many pore in the cross area. The researcher challenging is to reduce trap air so that the number of pores in the cross section of the material can be reduced. Yeah, I think it's the big problem. Yeah, if we want to make the material a composite based on polymer, especially polypropylene matrix. Yeah, it is understood that the strength of this composite is greatly influenced by the cross-sectional density. The presence of pores in the cross-section result in a reduced active cross-sectional area value, which of course reduce the material's ability to accept external load. Yeah. Okay, next. Next slides. Okay, thank you. Number three, the problem, we find the problem in the, my material is agglomeration. Yeah, I think it's a different of the, how the mixing, the ingredient to make, so to be a new material. This is the condition. It is known that in certain part, the coconut shell particles are in a state of accumulating, which could be caused by the incomplete mixing process. Yeah. By agglomerating the coconut shell particle, some of the particles are not bound to the matrix, making this particle easily separated and leaving holes. Yeah. This particle act as porous object is the cross section of the composite because they are unable to transfer the external force that occur. This condition causes the strength of the composite to decrease. Yeah. Number four, next. The strength of the material, composite material, we can to get a good strength, good properties. Yeah, if we know the geometry of the particle. Yeah, it is of very impact to the result, to the value of the strength of the material. In mechanical bonding, the geometry of irregular particle is better. Yeah, is better. Especially mechanical bonding, because the matrix provided better grip, yeah, on the particle. This condition can increase the strength of the material. It is very, very important. We can to think about the geometry of the particle. Okay, next. This is my research. I want to mix the reinforcement. Yeah, reinforcement from particle and fiber. Yeah, we just want to what can I do to give the properties, the strength of the material to increase. Yeah, we try to mix the reinforcement from the particle and fiber. Yeah. This is a process I did to make the lamina. Yeah, lamina is a composite mixed from the matrix polypropylene and bottom ash particle. Yeah. So next, thank you. And then this is a process to get together lamina to new material we call the laminate. Consists of several layers from laminate, and then the value of the composite material is better if we compare with before. Yeah. Okay. Next. This is the condition condition of the sisal fiber woven in the interlamina area in longitudinal direction. We can see fiber position in at interlamina. It's better. It's not to fracture. Yeah. While we do to make laminate. Yeah. Interlamina area and interfacing bonding of sisal fiber with lamina matrix. During bending loading, the fiber release from the matrix. Yeah. We can see the interface between matrix and reinforcement. Yeah. It's sometimes you can see it's not good interface, but in the other side, the interface is work well. Yeah. So, okay. Next. This is the properties and maybe the strength of the material laminate. Yeah, we found tensile strength and strain and elastic modulus. Yeah, we like the graph. We can see the value enough, yeah, good enough. So we can continues to the observe the material. I think we can to make the properties of the material increase by give treatment on the particle or on the fiber. Yeah, yeah. Okay. Next. This is a slide we can to show that the material can to form, yeah, can to make a product, yeah, that I see to need load is very low. Yeah, yeah. If we compare with metal material, yeah, we know by this material if we want to make the product, this need a low requirement. Yeah. Processing forming material is easy. Yeah, it's very easy. Yeah, and needs load pressing is low. Yeah, yeah. The material need heat to increase deformation. Before we form to the product, we give the heat. Yeah, we give the heat in the material, so we can to form easy because the material not very stiff. Yeah. Okay. Next. This is fiber. Yeah, fiber in the material. Yeah. Interlamina. Fiber in the interlamina. When we can see the forming process is able to rearrange the fiber structure to better. Yeah. An advantage of the process of the forming composite material from natural natural material with polypropylene matrix. Yeah, it's one of the value from this material. We can to rearrange the position of the fiber in the material after we give the load to forming to be a product. Yeah. Okay. Next. This I try to give the conclusion temporary because this research still going. Yeah. Composite material from natural have opportunity, yeah, to be engineering material alternative. Yeah. Reinforcement from natural fiber or particle chip capable of increasing the strength of matrix significant. This research is worth continuing. Yeah. I think it's enough. Thank you very much for your attention. Assalamualaikum.
Yeah, today we have a very, very interesting presentation because we can see from two different perspectives. From Dr. Yuri, we can understand about the purely mathematics, and from Dr. Made, we can learn about manufacturing, how to implement our knowledge in technology to make something applicable inventory. Okay, yeah. Okay.
Professor Madi, thank you for your very interesting talk. So you started from the proposition that my methods are not so are very far from your problem, yeah. But I believe it is not so far. They are not so far because all of these mathematical modeling of these cavitation processes or forming the domains on micro level, yeah, of particles. I think this concept of modulus of submetric can be used there. For example, so the distribution of these areas filled with some balls or particles, yeah, can be described in this sense. And after we have done it, we can formulate the technical process as the chain of physical transformations, which are described by physical laws such as conservative laws, for example, yes, or something like that, which are integral equations, once again, yeah, or differential equations. So I believe that if we have an opportunity to talk more about that, we can make it closer, our topics, yeah. So thank you.
Thank you.
We have to prepare the MOA after this,
yeah,
because
yeah.
we can see that
Yeah.
joint research will be have.
Thank you, Master Yuri. I am glad for your response, yeah, because we have different subject, yeah, but we can do connecting in the future. Yeah, I think, yeah. I hope we can do corporate mix work together, maybe to give the value of the material to better and better. Yeah. Thank you very much. Yeah. Okay.
Okay, nice. You don't need 1 hour, and after that we can already make a new joint research. Okay. Okay. We have finished the first parts. And now we'll move to the question and answer session. If you want to ask a question, please raise your hand. Don't forget to state your name and to whom the question are addressed. Please, if you want to ask. For the students, if you want to ask in Indonesia, it's okay. I will translate to the presenter. Are there any? Okay, Vladimir.
bird will eat such plastic, will it be dangerous for this animal or not? Because, you know, all the materials finally are wasted to the ocean. And this is a huge problem when you have plastics in ocean. So what do you think about this type of material?
Okay, thank you, Mr. Alec, for your question. Vladimir, sorry. Okay, this problem, the plastic maybe, yeah. But I want to find the new material from the natural. In this research, we use two material, natural and polymer. Yeah, but this polymer is not thermoset, but this polymer is a thermoplastic. We can do reduce and reuse and recycle. Yeah, not to damage for the environmental. Yeah, but I keep this to try to find the new material as a matrix from the natural. Yeah, until now we still to try to find it. Yeah, so we can maybe sometime we can to make the new material from completely natural. Yeah, the reinforcement and the matrix. Yeah, I think like that.
Okay, thank you.
Okay, there is someone text me to the question to Dr. Yuri. May I know what real implementation in the industry for the equations? Mild singularity kernels are quite interesting, but this is very interesting, especially for data mining. So is it also applicable for the data crawler in artificial intelligence?
Yes, definitely. I suppose so, because, well, there are not so many mathematical studies, as I see, analytical studies in this field. Most of the artificial intelligence works are on applications, mostly, yeah. And it is quite interesting to estimate some basic properties of the algorithms used. And in this case, for example, this transformation of one ball to another, yeah, which is called like submetry or is close to submetry, is some sort of algorithm. So it can be considered as some sort of algorithm which transforms this data spread in this way. And it is quite interesting how different algorithms react to this description. So, and I think, I don't know personally, yeah, I don't know such kind of works, but I hope they will appear soon, and I will be glad to participate in such a study. So, yeah, thank you for the question.
Yeah, maybe others? Okay, Ms. Professor Xu.
Okay. This keynote speaker and from the Russia and Indonesia, I suggest is very perfect about some Yuri. It's just research about some mathematical, especially singularity function, like you mentioned about although abstract mathematics, but is like the physical ball, like the ball, and also in the mathematical, like the conjecture, point conjecture about some is near the fraud, like if something enclosed is like the ball, and also you do many analytic and analysis, and another Professor Mati just mentioned about like the fiber, some material, especially strength. And I know in Russia, in some research in the helicopter. Like a helicopter, the wind is near to strengths, that fiber and some strengths. So I suggest next stage combine some so mathematical analysis, some new material is how to enhance the strengths and combine that. That's fine. That is my suggestion. Thank you.
Maybe others have a question? If not, maybe I have a question, Dr. Yuri. If I'm mistaken, I hear that you say that the formula that you explain is also used in the construction field. Yeah, the construction field.
I've made some research on applying this to, for now, for ferroelectrical modeling, yeah? But construction, it is quite interesting issue. It is a quite interesting issue, but I have no ideas for now how to do it, yeah. So I would say that this fundamental mathematical knowledge can be applied everywhere where mathematics is applied, yeah? So, and even in numerical methods, all of these is like the analogous for conditioning of equations, of the describing of the errors. So, and in this way, it can be applied even in construction mechanics also, yeah.
Okay, because if you can see the potential to join research with the manufacturing, I think there is a possibility also with friends from the civil engineering to
I need to think about it first. Yeah, the presentation of Professor Mandi was so clear that these ideas just came up, and
okay.
So we are waiting for your presentation.
Yeah, okay. Yeah, maybe Mrs. Dika, we can prepare for that. Join the topics.
Thank you.
Okay.